So, last of our ways of showing our data. Box-and-Whisker Plots gets its name from exactly what it looks like. It looks like you're going to have a box and there's going to be whiskers coming off the end of it. So just to get us prepped for that, we've got a couple of things up here at the top we're going to look at. So we need to order the test scores from least to greatest. You never know what this is going to be coming towards. So what number is going to come first? 79. And just me, I would just start crossing them off as I was dealing with them. So as you do this, and you're like, okay, so what's the point? What's the point of doing this when I've got the numbers there already? Well, you remember enough from what we've been doing in our other data sets to know that as we're doing these, to do mode, well not mode necessarily, but to do median, what we're being asked to find in number 2, it's kind of important to have the numbers in order. So what's my median going to be from this list? If I start working my way in from the edge until my writing utensils come together, my median ends up being 89. If there were 2 numbers in the middle together, we'd add them up and divide by 2. Okay? So that's not really a big deal. But we're going to start doing some things like number 3. Now this is a little different than what we've been up to before. What are the possible values of x in the data set 22, 12, 33, 25, and x if the median is 25? Okay, so first thing, I need my numbers to be in order. So, what order am I going to have these 4 in? Not everybody at once. Oh, some of you, it clicks a lot better if you kind of work yourselves in and participate some with this. Now you're like, okay, but I got this number x to deal with. You know, what's the deal here? Well, let's think about this for a second. I have one more number, okay, this x that's sitting here. If I want the median to be 25, can this value of x be like 10? Because if it was 10, then I'd have 3 numbers over here, and this wouldn't be in the middle. So to make sure this stays in the middle like it is now, okay, it could be bigger than 33. It could even be bigger than 25, because then I could tuck it in here and it would still work, okay? So here, and this is a little different, it's a little more abstract, any number greater than 25 actually would work, because if it was 26 to 33, I would just tuck it in here, and I'd have 2 numbers on the right and 2 numbers on the left. If it was bigger than 33, and I stuck it here, again, I have 2 numbers on the left and 2 numbers on the right. So when I come into the middle, I get a value. So it's not necessarily just one specific number. Even though if you said, well, 35 would work, that's fine, because you're showing me you understand where the x value would have to be, okay? But it would cover any of those. And it could be equal to 25 too. Could it be equal to 25? It could be equal to 25. That's very well thought out. I agree with you that we could even do it that way, because the 2 25s, one of them would cancel out and the other one would be my median. So I'm absolutely in agreement with you on that. So then, when we get to the next part here with our table, we've got a table that summarizes the veterans' records for kitten litters born in a given year. So I had 1 that was 2, I had 6 of them that were 3, mercy. 8 that were 4, 11 that were 5, and 1 that had 6 kittens at a time. Yeah, I'll go with 0 on that. While central tendency describes the middle of a data set, okay, again, just a fancy word for when we talk about a median, okay, there's a word called variability that describes how spread out the data is, because you may have some of the same ending and beginning values, but you may have a lot more values in one area than another, and that makes a difference in, you know, what my data says. So, as I push this up, because I'm about to run out of room, okay, there's pieces of this data that we need to understand, you know, what they're called. So, we're going to divide our data into 4 parts, 4 equal parts. And those are called quartiles. So just like quarters are a quarter of a dollar, quartiles are the 4 different pieces of our data. Okay. So we have the median. Okay, I'm going to skip one here. Our second quartile, and I just call it Q2, almost like quarter 2, okay, is the median of the entire set. Any of you that do sports, you could be like, oh, well, the median's in the middle. It's kind of like halftime, right after the second quarter, okay? But there's also going to be 2 other parts to this. And I'll explain this all in detail as we're going, so don't worry if something's not going perfect right now. I can also find the median of just the lower half of my data, and that's called the first quartile. Sometimes it also can have another name. It can also be called the lower quartile. Okay? Those are interchangeable. First quartile, lower quartile. And lower makes sense because it's from the lower half of where my data is at. My second quartile still is the median. Okay? Those are interchangeable. And you'll never guess what the median of the upper half is called. What comes next?
5, 3.
Okay, first, second, the third quartile, okay, is the median of our upper half. And again, since it's of the upper half, sometimes it's called the upper quartile. Again, makes sense. And it'll make more sense when we actually start calculating it. You'll be like, oh, okay, I kind of see what you're up to here. But these allow us to find all 4 of those data portions. So for instance, if we took our kitten data and wrote it all out, okay, that's what we're going to see down here below. We're taking this chart and we're turning it into this data, because you'll notice there's 1, 2, there's 1, 2, 3, 4, 5, 6 threes. 1, 2, 3, 4, 5, 6, 7, 8 fours, 11 fives, and 1 6. So we write the data in order, okay? We put all of those values in order. And now what we're going to do is we're actually going to calculate what these quartiles are, okay? So I always have to make sure that before I start trying to do this, that all of my values are in order from least to greatest. I have to have that done that way or this doesn't work. So once I have that done, my first job, once I have them in order, is to find the median of the data set. Now, like we did before, and even though it's done for us this time, it's something we want to take a peek at. If I started counting in from the edges until I got to the middle, okay, I'd find out that my median this time equals 4. Okay, that's my second quartile. That's another name I could use for it, and we've got that up here. Once I know what that is, now what I can do is I can find my first quartile and my third quartile, otherwise known as my upper and lower quartiles. Just to make sure that we kind of get used to some of the language, let me put those in. Okay, so to find my upper and my lower half, I keep out the part that's my median, and I just take all of those other values. Okay, that becomes my lower half. Or if I have all of my values that come after the median, okay, those are my upper half. And once I have those, I can actually find my quartiles. Okay, so we're going to find the medians of those, and that will actually give me my first and my second quartile. So we do that just like we find a median for anything else. I take my lower half, and I start at the edges, and I start counting in towards the middle. And I don't skip some. When I get to the middle, whatever that number is in the middle is my first quartile. Okay? So it's just the median of the lower half. It's 3. I do the same thing for my upper half, and I find out in the upper half it's 5. Okay? And if there's 2 numbers in the middle, you just add them up and divide by 2. So it's actually just like finding 3 medians in the problem instead of just finding 1. And the reason you do that is sometimes with data, you find out that your median's way towards one end or the other, and it's not evenly distributed. Something that's kind of important when you're looking at, business data or something like that. So here's what we're going to do. We're going to get a little more practice here. We're actually going to start doing some of this instead of having it all done for us. All right, so example 1. Find the first and third quartiles for this data set. All right. We got to put these guys in order first. So hopefully we do a solid job here of getting these put into order. So once I get them put into order, I'm going to be able to start figuring out the pieces of this that I need. So here's how this works. What's my median for this one? What number's in the middle? 21. Okay. So 21 is my median, or my second quartile. What's that? Yep. What we're going to do once we've got that figured out is we're going to break this into my lower half and my upper half. And all I'm going to do then is look for the median in each of those individually. So my middle number in my lower half, which is my first quartile, my Q1 is 15. And my middle number in my upper half is that median, or my third quartile. And I have all the values that I'm looking for. And that's all I'm doing with these. So it's just like what we've been doing, still finding the median. It's just finding the median of each half then. So here's what, here's what I want you to do for a minute. So on example 2, I want you to put these in order, and then I want you to find the first and third quartiles for each. So I am going to cover up what I am up to here for a minute, and I want you to put your values in order, and then find your median. And from there, you can do your 2 halves. Ooh, I am going to give you a heads up on this. All right, Hardy's going to uncover this. If I'm looking for my first and third quartiles, I do want to give you a heads up. If your median would split these in the middle, like it would here, okay, since there's an even number of numbers, there's 4 on each side, I'm going to split them evenly as though I don't have a median there. So if I was looking for the actual median of this, I still would add up the 2 in the middle and divide by 2. So my median would still be 48 because I have 2 numbers in the middle. I find their average. But when I go to find my first and third quartile, I'm including those numbers. So the only time I get to ignore the median is if it's a single number in the middle, like it was in example 1. But if it's an evenly split data set, I'm going to just do it this way. So when you split them up, you're like, well, then I don't have a single number in the middle. There's 2 of them. That's true. So my median will be based off of those 2 numbers for my lower quartile and those 2 numbers for my upper. So if that's true, if I add up the 2 numbers boxed in green and divide by 2, I get 39, so that would be my first quartile. What if I add up the 2 in my blue box? And 54, okay? So that's a very important thing to remember, and it's good that you'll have it in the notes, because then if you get confused sometime, it'll be right here. If I have a single number in the middle for my median, we don't include that looking for our first and our third quartile. If our median value in the middle takes up 2 numbers, okay, then I do use those in finding my other data. So that's a little bit interesting. So you're like, okay, we're just going to put numbers in order and find these averages and we're done. Well, no, there's a way to visually see this, just like we've done with our other plots. So this is called, as I mentioned before, a box and whisker plot. Okay, and that's going to visually let me see how this data gets spread out. So the middle half of the data gets represented by the box part, like you can see below. And then there's a vertical line that I put in when I find the median. And then the lower fourth and upper fourth quarters are represented by what's called a whisker, or a line that's outside of my value. So my first quartile, my median, and my third quartile, okay, when I find those 3 values, like I did in the first and second examples, they're going to create my box. Any value outside of that is going to be my whisker. And you're like, that's a lot to deal with. But it's not really once you actually get to start playing with it a little bit. And there's only one more bit of vocab here. There's this thing called the interquartile range, which is the difference between the first and the third quartiles. So in other words, all of this data that's in the box is called my interquartile range. And it's just, if I took my Q3 minus my Q1, that would get me that. And that's going to represent the middle half of my data, from 25% to 75% of everything that's going on. So whenever you're doing data, is there going to be an exception to the rule? I mean, if you have, like for instance, me as a teacher, if I was making a box and whisker plot of a quiz, and most of you are getting 60s, 70s, a few 80s, but somebody sits and doesn't take it and gets a 0, okay, that would be kind of way outside the box here. And those things are called extremes. So like if everybody else is getting a C and somebody else gets 100, that'd be an extreme. Or like we said, everybody else is getting C's and B's and somebody gets a 0. Okay, that would be an extreme. So the lower extreme is just my smallest number, and the upper extreme is going to be my largest. And we're finally going to get to put one of these together and start seeing how this all comes together. So for our third example, we're going to draw a box and whisker plot for this data that's given. I'm going to scooch this over so we actually get all the data in. So my first job is to get these put back into order. So let's see here. So we got 13, 15, 17, couple of 19s, couple of 21s, and a 25. All right. So now we can start finding the pieces that we want. So the first question is, what's the range of the data? So from biggest to smallest, how far is that? Okay, 12, because I just do the biggest minus the smallest. Okay, so that's going to be 12. The data is going to get divided into 4 parts. Now again, here's how this works. First job, I count to see how many numbers there's going to be so I can figure out my median and all this other stuff. So I start counting in from the edges. Well, I have 2 median numbers, but they're the same. So I find out here that my median is 19. Because again, if I count in from the edges, those are the 2 numbers in the middle. If I add 1, divide by 2, I get the number back. So here, I say, okay, there's my lower half. Here's my upper half. And I need to find the median of each of those. So I look at my lower half and I say, well, there's 4 numbers here. So it looks like I'm going to have to add those 2 guys up and divide by 2, which would be 16, which is my first quartile. Over here, yep, if I count in from the edges, I get 2 numbers, but if I add 21 and divide by 2, I still get 21. So that's my second quartile. And then for the first time, we get to label some extremes. My lower extreme is the smallest number. Okay, so we call that my LE. And then my biggest number is my upper extreme, which would be a UE. So you're like, dang, Hardy, every number in here is getting labeled. Basically, but this is kind of a small data set. So, remember, we'll get our other data, and then we'll actually draw the plot here. My IQR is my did I just write Q2? Hardy. Silly man. Q2 is the median. That's Q3. Q3, my third quartile minus my first quartile, is going to be my IQR. So 21 minus 16 would be 5. Subtract that. And then what percent of values will be within the box? Well, we just got done at what you can see at the very top of the screen. The IQR always represents 50% of the data. So 50% of my values will be in the box. And let me show you how this works now. When I go to draw it, I am going to take my Q1. I'm going to make a line. I'm going to take my Q3, 20 and 22. 21's right in the middle. Draw a line. And my median, 19. I'm going to draw a line. And then when those lines are drawn, I'm going to make a box out of them by drawing a couple of horizontal lines in. And then the only part I have left is to look for my 2 extremes. At 13, I'll put a dot. And at 25, I'll put a dot. And I just connect that to my box with lines, hence a box and whisker plot. And what this would tell me is my median's a little bit further to the right of my data. So my scores, if they're test scores, are going to be a little bit higher in this case. But I get to see sometimes these whiskers can be really short or they can be really long if there's something that's kind of out of the ordinary. So nothing too bad going here. So then, you're like, oh my gosh, there's a then. So when we get to the back here, and we're almost done, because example 5 I'm not going to worry about as much. So this should be the last one we're going to play with here, start to finish. So draw a box and whisker for the following set of data. All right. They're like, crap, you didn't put it in order, Hardy. What is your deal? Well, sorry, let's see here. Again, put them in order first. I got to be careful about this. This is why the data geeks, I mean the statisticians, end up making decent amounts of money, because this is, even when you've got computers doing parts of this, this can be a bit time consuming. Oh, Hardy, what'd I do? Forgot the 59. All right. Again, another advertisement for why I shouldn't be using a pen right now. All right, let me make sure I'm good again here. 56, 58, 59, 60, 61, 61. Okay, now I'm good. 62, and a couple of 63s. Okay. Again, once I get that part set, now my job is to go in and find my pieces of this that I need. So I'm like, all right. I have a single median this time, which means it will not be included when I am trying to figure out my first and my third quartiles. And you can get decimals sometimes for these. That's not a bad thing. So if I'm trying to find my median, I got two values here again. Yep. So my first quartile is 58.5, because I'd add those two up and divide by 2. Same deal going here. I end up with two numbers in the middle when I bring my fingers together. And I'll add those up and divide by 2. And if I put my numbers correctly in order, my lower extreme and my upper extreme should be fairly easy to find. And then I can make my plot from this. Because again, I'm going to take my first quartile, 58.5 or thereabouts, my median, 61, and my third quartile, 62.5, and make a box. And then for my extremes, I'm just going to plot a single point. And you see the upper extreme really isn't that far outside the box. Ha ha, math joke. But 56 is quite a ways. So that one was kind of unusual compared to what everybody else seemed to be getting. But that's how this whole box and plot thing works, this box and whisker plot. So what can I actually take from it? Okay. Can I use a box and whisker plot to find the mean or the average? Well, no. Okay. Can I use it to find the mode? No, because the actual numbers aren't here. I don't know what number showed up most often. Now, if I look at the list, I can see 61 and 63 show up the most often. But I can't tell that just by looking at the plot. The median? Absolutely. Because I have a line for that right here. Okay, my range. Absolutely, I can look at my two extremes and then subtract them. Okay. The number of items that I have in the set, no. I mean, this data could be for 500 scores instead of 10. And then finally, if I've got a long box or a long whisker, okay, that's kind of out here, that tells me that my data is really spread out. That, you know, if we're talking test scores, they're all over the place. They might be in the 30s, the 50s, the 80s. We don't know. It's not like everybody's getting the same score. If it's a small box or a tiny whisker, sort of like our 63 was up above, okay, my data is short in range, okay? That there's just not a whole lot of difference. Everybody seems to be getting 70s on the tests, okay? And kind of working it out from there. And then we're not going to worry about example 5 because we just want to worry about doing the basics right now. So that's all fine and good. Keep this in a spot because, again, shoot, especially on a quiz, if I ask you to draw a box and whisker and then you forget and all those points are missing, shoot, having this just to help you out, very good thing. So all you are going to do on this worksheet, as you start to look through them, is sometimes the box and whisker will be done for you. So all you might want to do is possibly label the parts because it might be easier to deal with the questions then. Okay, there's my third quartile, my first quartile, and my median, or my Q2. Because then I can yank those right off of there, or I can yank the answers right off of my note sheet. But if you start to get asked a question, and there's one other question on this front page I want to look at, because then I'm just going to make one mention inside the packet. I'm going to set you off here on your own. When I come up to number 2 here momentarily, it says, what is the median of the following box and whisker plot? Okay, that I can handle. Looks like the median is 35. Okay, that's no big deal. What percentage of the data is below the median? Now, we'd mentioned before, this box and whisker cuts it into 4 equal parts. So even though a part of the box might be bigger or a part of the whisker might be bigger, they still represent the same proportions of the data, which means every part of this, each part of the box, okay, even though this is little and this is big, they each have 25% of the data in, and so does this last part. So if you're asked, what percentage of the data is below the median? 50% of it is. And that'll always be true, no matter what your plot looks like. What's that? Okay, what percentage of the data is below the median? If my median's right here, I've got this part of my box that's 25%, and this whisker that's another 25%. I just add those up to get what percentage of the data would be here. Because then if it asked me what percentage is above the median, it'd also be 50, because I'd just add those up. Now, I'm going to flip to the inside here. Here is what I want you to be up to. Okay, what's the 5-number summary? You're like, 5-number summary? I want to know, okay, the 5 pieces: the median, the first quartile, the third quartile, the lower extreme, and the upper extreme. 5 things, 5-number summary. Okay, they're just using the actual data terms for these things to make that make a little more sense. And when you get to the last page, alas, I am not crazy. Because some of you might have already looked there and go, really, Hardy? You really think that? Yeah, no. A couple of nice things about the last page, though. Number 1, it gives you a play-by-play of exactly how to draw these. Okay, but for the ones that we are going to do, we are only doing box and whiskers for the evens. Okay? Evens only on this page. So box and whisker plots for 2, 4, 6, 8, and 10, you can either do them on the back of this sheet because it's blank, or if you wanted like a piece of graph paper or something, I've got some of that available too. But that's what we're going to be doing. And tomorrow we're just going to go back through some more of these and just get some more practice. Because then by Wednesday next week, Wednesday, Tuesday, Wednesday, probably Wednesday of next week, we'll be ready for a quiz on all of these. We'll do a review ahead, like we always do. And that way Thursday we can kind of kick back a little bit before break. So that is the plan.